Welcome, everyone. Thanks for joining our webinar this morning. We'll probably wait one more minute here just to let everybody get logged in.
Hello.
Hi.
Just to introduce my colleagues here. I'm joined by Friedemann Stang, Application Support Specialist, and Michael Kohnen, Global Manager of Application Support. They'll be making sure that all of your questions get answered and taken care of during the webinar here. All right, so our topic for this session is designing a lower partial with overdenture. So we're going to be taking a look at new workflows introduced in PlavDiv that really help out with this workflow. If you have questions during the webinar, feel free to type those in your question text box in the GoToWebinar panel. Just make sure you're really specific about anything that you ask, a certain feature or part of the presentation, and that way Friedemann and Michael can answer your question accurately and get those done quickly. And then also, the webinars will be recorded, so we'll show this again at the end, but you can see the recordings and the rest of our webinar schedule at exocad.com/webinars.
Okay.
The topic for today, designing overdenture on partials. This is a new feature that we've just introduced in PlavDiv. It's a smooth, seamless combination of PartialCAD and DentalCAD that allows you to design a framework in PartialCAD, have that framework design pulled right into DentalCAD, and design the overdenture structure. And the designs are free of undercuts and can be placed right on top of the partial framework. The technical description, this talks about how DentalCAD allows the overdenture design on existing partials, and it generates the tooth pockets for Pontic models. And then DentalCAD automatically detects the PartialCAD designs and loads the related wizard steps for those. And then the blackout gingiva step considers the partial framework when it calculates that surface and blocks out undercuts on the framework. And then there's a really cool step, I will show you this as well. That framework file that gets pulled into DentalCAD, we can freeform edit that partial framework, keeping you from having to go all the way back into PartialCAD if there's something you need to adjust on the framework. The case that we're going to show everyone today, we have 3 phases. So we're going to start off in DentalCAD, place the Pontics that we're going to use later in the overdenture design, go and launch PartialCAD to design the lower framework part of the case, and then we're going to go back to DentalCAD and import the lower framework and design the overdenture. So it seems like a lot of steps, but you'll see how kind of easy and seamless it is to switch between those different steps here. So let's pull up our software. So in DB, let's take a look at how you would set up a case like this. So this is our example here. Pretty simple to set up. We just need to remember to indicate the partial framework work type for each tooth that you want to replace and have in the overdenture. So I have 3 teeth on either side of the lower arch. Just for example, I click on tooth number 31. Under appliances and removables, we have the partial work type selected and an NP metal laser material selected. Options over on this side. Blackout angle, we can adjust that here, and support bar, we have that set to no for this case. Then we just repeat that setting for these 6 teeth here. So nothing really extra we have to indicate in DB for this workflow. The main things we have to remember, since design partial is a separate action button over here, we just need to go and start off in DentalCAD by clicking the design button. So this is our first phase where we're going to place Pontic teeth on our model. So click design to launch DentalCAD. The software is going to load our lower model with our partial design drawn on it in a texture scan. And then the first wizard step, place tooth models, comes up. So now it's asking us to place the teeth for 29 to 31 and place a mesial contact for tooth 29. So it's going to left click on the model here Drag our teeth back until they're approximately the size that we need them, and then left click on the ridge. So it's kind of hard to see that point underneath the tooth, but I just left click and place that yellow point down on the ridge for the second molar there. Also here, we have the option of changing DentalCAD tooth library. Any of the libraries that are available in DentalCAD can be selected for this workflow here. If that tooth setup looks good, we're going to click Next. And now it's asking us to place teeth 18 to 21. So I'm going to place the mesial contact on tooth 20. And then again, I'll drag that tooth section back and place a point on the ridge for the second molar. That position looks good, so we'll click Next. Now we have the tooth placement section step in the wizard. I'm going to click on chain mode. Easiest way to manipulate a group of teeth like this. So the dark blue disc, the posterior of the second molar, I'm going to left click on that and raise the molars up a little bit. I can also move that left or right to scale all three teeth at the same time. Let's look at our arch form from a couple different angles. Then do that again on the patient's right side here. I don't have an opposing scan imported for this case, but if we did, we'd use that here as well to help us position these teeth. Now I'm going to switch to single mode in chain mode. This will allow us to do some adjustments individually on the teeth without affecting the adjacent teeth. So I can hold down Control on the keyboard to rotate, and then the Shift key for scaling. Just going through and making sure that these are positioned where we need these. Once our tooth setup looks good, everything is in position, we can click Next. So now we're at a freeform step. Now we can freely edit the anatomy and profiles of these teeth. So we have our anatomic tools. If you're familiar with DentalCAD already, you know these tools pretty well. And then a freeform tab, we have Add, Remove, and Smooth tools. So I'm going to go in and just broaden our contact areas just a little bit here. Just going through and making any adjustments to anatomy and shape of the teeth that we want to do. Then I'm going to go over to the Adapt tab. Two things that we need to trim here. So first one, we're on Pontic. I'm going to adapt this to the gingiva. Then we'll go over to the Approximal tab and cut our contact settings. So right now we're at 0. I'm just going to click on Cut Intersections to cut our contacts. I'm just going to jump back to the Free tab and use the Smooth tool just to shape up our Pontics a little bit here. Any areas that are protruding down a little too far, we can use a smoothing tool to quickly trim that up a little bit. All right, that looks great. Okay, let's click Next. So now DentalCAD is going to save our Pontic shapes as STL files. And then since we have the order in DB set up with the partial work type, we have this option here that says PartialCAD Design. So that was our first phase, setting the teeth. And now we're going to jump to the next step. And after I click Next, PartialCAD will launch. And these 6 teeth shapes will be pulled into PartialCAD as we design a framework. All right, so this interface, you can tell right off the bat, looks slightly different from DentalCAD. So we have our model scan, and then you can see they've been set to translucent about halfway through. You can see our teeth, our pontics that were designed in DentalCAD. Just a quick overview of the user interface in PartialCAD. In the upper left-hand corner, similar to DentalCAD, each item has a checkbox and a slider for visibility to adjust translucency. The wizard in PartialCAD is this bar along the bottom of the screen. The lower left corner will always show the current step that you're on, and then applicable settings and tools for that step will show up across the bottom of the screen. Those are our undo button, and then our back and next buttons are in the lower right corner. And then in the upper right corner is the button to switch to expert mode. So this first step that we're on in PartialCAD is called the survey model step. So this is where we can rotate the model and change the insertion direction of the framework. So that sub view in the upper right corner, this is showing us if the model is level as we rotate it. So you can see as I move that back and forth, that changes in the secondary view. And that's also showing us a better view of our undercuts in the anterior region. So if I update the model, click on Set from View, the undercut color will update. And our option here, we can change the draft angle if we need to set a different angle for blocking out undercuts. And if for some reason we don't want any virtual blackout, we can uncheck blackout undercuts over here. So that position looks good. I'll click Apply. Oh, there we go. It wasn't set from view. Okay, so I have to go back and click set from view and then apply. Okay, so now our virtual blackout step is calculating. So when this calculation is finished, you'll see kind of a teal colored virtual blackout wax show up in a few seconds here. So that's all the area that was blocked out with our virtual wax. And if we rotate our model, we can see that in the main view as well. So I'm going to go down to the lower right corner, click Next. Now we're at the step called Edit Blackout. So this is where we need to remove blackout wax and reveal undercut areas that we want to use for clasp engagement, areas that we want the clasps to go into. So the tool that it starts off with by default here is called Smudge, and that's a really good tool that allows us to quickly remove wax material. So just left clicking and dragging. And then we can see some undercut color maps show up as we open up some of those undercut areas. So let's go and do that on the other side here. The other tool we have here is a smooth tool. So any areas that you want to soften the edges, you can do that with the smooth tool. There's also a couple options for this tool here. You can do additive smooth, which will do smoothing and add some material back onto the surface. So if there's any areas where you want to gradually fill in the undercut area a little bit, you can do that as well. And then subtractive smooth, which does the same thing in reverse, removes material as it keeps the surface smooth. And you can adjust your tool diameter and smooth level. So when you move that slider to the left, the tool becomes less effective. It does less smoothing as you drag it. So the goal here is just to open up any undercut areas we need for the clasp step. Once we're finished with that, that looks pretty good. We can click Next. The next wizard step is draw bar and mesh. So now we need to tell the software where we want the bar to be located, as well as the retention mesh areas. And to put these parts on the model. We do that by drawing what's called curves. So we can start in either order. Usually I'll just start with the curve for the bar. So it's going to left click approximately where the bar will start, and then just keep placing points and draw a single line roughly halfway, or right in the middle of where our bar is drawn on the model. So we're not outlining the entire bar, just placing a single line through the center really. And then double click on that last point to finish it. So then we end up with our blue line there. So then we do a similar process for telling the software where the retention mesh areas are going to be. So I'll start over here and just start clicking points. For this feature, we are going to create an enclosed line. So keep going back and then double click back on the first point. Got a couple extra points we need to remove here. There we go. Okay, so to edit a curve, I'm going to go down and click on Edit Curve. Click on that first line, and then you'll see those control points that we placed show back up here. So we can click on any of those and adjust their position. Okay, that one looks good. So I'm going to go back and click on Draw New Curve, and then draw the other outline for retention on the other side. Double click on the first point to close. And then we're going to draw two additional outlines here that we're going to use for tissue stop features. So I'm just going to go ahead and draw small outlines back here. Let's adjust that shape a little bit here. There we go, that looks good. So now I'm going to go back to draw a new curve and do the same on the other side for our other tissue stop. Draw a small circle, double click to close, and then we have all of our features drawn in this section. So I'm going to click next. Oh, let's do that. I get an extra point clicked here, straight control point. All right, click next. So at this step, apply mesh, this is where we turn those outlines into actual features in the framework. The first two that the software selected when we got to this step were the smaller circles I drew for the tissue stops. So I don't really want the whole pattern applied for that. So I'm going to go over to the pattern dropdown, change that to smooth. And then also we have 0.6 millimeters of relief wax thickness under those. So since I want those right down against the tissue, I'm going to change that to 0. And then go and click Apply. So now the software is generated in the virtual wax material there, our two tissue stop circles right against the surface of the ridge. So now I need to repeat that for the other areas of retention mesh. And for those, I do want the whole pattern. So I have the round selected for the whole pattern. And then these, I do want relief wax underneath. So I'm going to change that back to our 0.6 millimeter setting. And then to apply these settings to another section for retention mesh, I'm just going to go and left click on the outline of the area I want to apply that shape to. Oh, that stayed to smooth pattern. There we go, there's the round pattern. So in this, the white areas are going to be holes through the material, and the black color is going to be the wax or the metal material. So here we have a rotation control. If I hover the cursor over that first dot on our arrows here, that allows us to rotate the pattern. And then right at the end on the triangles, that allows us to scale the pattern. So I'm going to scale that to a hole size of about 4.5 millimeters. And we can see that at the bottom of the screen for hole size that adjusts as I scale it. So we can either adjust it with the slider, type in a value, or use the controls on the screen to adjust that size. Then if I go to that center dot here, left click and drag, I can move the pattern. So the goal here is I'm trying to get the pattern adjusted in a way that I'm going to have metal surface up here to connect to our minor connector, and metal surface back here where our tissue stop is going to be. All right, that looks pretty good right there. So once that's in position, I'll click apply. Now the software is going to turn that into the wax feature of the retention mesh. I'm just going to go and repeat that on the other side. So I'll click on the other outline. Change that to a round pattern here. Rotate to get that aligned where we want, and then again, change the whole pattern to about 4.5 millimeters. And then again, I'm just going to line this up so that we have metal up here to connect to our minor connector, and back here for the tissue stop. All right, that looks pretty good. We'll click apply. All right, so that's everything we need to do in this step for applying meshes. So I'm going to click next. This step here is applying the bar profile to that curve we drew up here for the bar. So at this step, you can see the control points we placed earlier for that line. We can click and drag those to change the position of the bar on the model. There are different profiles that can be selected for the bar. A couple in there by default, and then you can also come in here and custom define profiles for the bars and the clasps as well in that step. I can click on this button, launches this screen, and this lets us click and drag and kind of change the profile, and then this can be saved as a custom profile in the software that will show up in your dropdown for future cases. Just going to discard changes for now. I just need to reapply our standard bar profile. Okay, there we go. So that position looks pretty good. I don't really need to do much else to adjust that here. I might extend that a little closer to our retention mesh. That position looks okay. So let's click next again. Next step in the wizard is to draw an apron. This is optional if you want to draw that support structure to help with anterior tooth support. For this particular case, I won't be using an apron, so we're just going to click next to skip past that step. Now we're at the step to draw the clasps. So similar to the line that we drew for the bar before, I'm just going to left click and start placing points roughly through the midline of the center line of where we want the clasp to be positioned. And then double click on the last point. And that line's editable. The position is once we get to the step where we apply the clasp profiles. So let's go ahead and place the second curve here for our other clasp. And those are the only two for this case, so I'm going to click next here. Now we're at the screen to apply the profiles to the clasps. Again, similar to the bar, we can change to different profiles if we need to, and save a custom profile if you want to as well here. So I'm going to leave that on anterior profile. To apply that profile to one of the clasps, I just need to left click on the line that we drew previously, and then you can see that profile show up. And then we can click and drag on these blue control points to change its position here. So if you decide the line's not quite in the right position after you apply a profile to it, we can adjust that pretty easily here. Once that clasp is positioned the way we want it with the correct profile, I just need to go down and click apply to save that as part of the structure here. And then I can go and apply that profile to our other line. Same thing, we'll just see if that needs any adjustments in position. Okay, that should suffice. We'll click apply to save that clasp. And once we're finished with all the clasps on the case, we can click next. Now we're at the step called fill and wax clone. So this step, any of the other components that we're missing, we use the tools in this step to create those. So two tools here, we can adjust the tool size, the cursor diameter, and the thickness of material that's applied. So then towards the center of the wizard tool here, we have different presets depending on what type of feature that you're looking to place. So let's start with occlusal rest. So that changed our settings to the presets for occlusal rest. And then just come over with this cursor, left click and drag to place material on the model. I'll do that for other occlusal rest over here. Now I'm going to switch over to the mesh preset and then fill in some area around our retention mesh and bar. Then I'm going to fill in some of these retention holes to make this a solid surface. That's going to leave this row up on top of the ridge here. So when I use this tool over the relief wax, it's going to create that same mesh thickness on top of the relief wax surface. And then anywhere I place it outside of the relief wax, it's going to be placed right up against the surface of the model scan. That'll be a smoothing tool that we can use later on to blend and create smoother transitions between our different levels here. Make that all look connected and uniform here. Then to finish that smaller section there, I'm just going to change the tool size diameter and make that a little smaller here. All right, then let's repeat that on the other side. Fill in some of our retention holes. Then switch the cursor to the tool size a little smaller to get that last area here. And then let's see, the last feature I think we'll do here is the minor connectors. So I'll switch to the minor connector preset and place some material here connecting up to where our clasps are. And then same thing on the other side. Okay. Let's click next. Now we're at the step where we need to place the finish lines, which will be the transition between the metal and the resin or acrylic work on this side here. So same thing as our clasp and bar features, just going to left click and start placing some points here. Double click to finish. Then we'll draw one on the other side. And then to edit the finish lines, we'll go to the next step. There you can see the control points we placed. And then there's a maroon control point here. We can adjust the rotation. So if it doesn't look correct right when it loads, we probably just need to rotate the profile there. There we go. That looks better. I'm going to rotate that a little more. A few more degrees here. And same thing here. We can left click and drag those control points if we want to change the position of the finish line. We'll go over and adjust the one on the other side. So adjusting the position slightly. Okay. As the finish line is in position, let's jump to the next step here. So now we're at the step called add part. So this is another optional step. This is where if we're going to use any Pontic models as metal backings or dummy teeth or load in a custom file, we can do that here. That's not needed for this case, so we're going to skip past that part. Then we get to a step called edit wax. So this is where we can use a smoothing tool and really kind of clean up the framework and transitions between different material thicknesses here. So default tool it starts on is smoothing tool. Again, we can set the tool diameter and smooth level, and it starts off on level smoothing. Let's clean up that transition to the finish line here. Now you can switch to additive smooth. Maybe we need to add a little more material with that transition of our bar here. We can add a little material there. Make that section a little thicker at that junction. Then go and smooth on the other side. Smooth around our occlusal rest, a minor connector. Just smooth inside of the finish line a little bit and right along the edge. There we go. Create a nice rounded edge there. Last thing I'll do, I just want to add a little material thickness back where our tissue stops are. I'll just thicken that up a little bit. So we're using additive smooth. Just add some material there. Once your framework is cleaned up and pretty polished looking, we're finished with this step, so we can click next. The build step is really the last step in framework design. Here we'd click save to build to save the case and generate the file. Just one thing I'll point out here, sometimes I get asked if it's possible to save this scan with the blackout wax as a separate file for a model, and you can do that by clicking on the save a drafted refractory checkbox here, and when it saves the case, it'll save a separate file in the project directory with that blackout on the model scan. So let's go ahead and click save for build here to save our case. So it's going to generate the STL file, and then as we move into the next phase of our design here, we'll go back to DentalCAD. DentalCAD will detect that partial framework file and pull that in for our overdenture design. Let's take a few more seconds to save here. All right, it's finishing up. All right, so there's our finished framework file. We can see the underside. We'll click Done to close out of PartialCAD. And now you can see right away, right when I get back to DentalCAD, this message comes up and it says that it's detected the partial framework design, and it asks if I want to load that into DentalCAD. So I'm going to click on Load Existing Partial Framework Designs Now. And then another option shows up over in the DentalCAD wizard, Design Overdenture Gingiva. So that step is highlighted, so I can click Next. And we'll save our scene. So the first step that comes up in the wizard now is the virtual wax up bottom step. So this is going to calculate the surface that will be used for the underside of the overdenture and take into account the partial framework file on our model and block out undercuts over that. So we just need to set up our insertion direction, adjust that if we need to. You can click Set Insertion Direction from View. Before we click Apply, you can also change the bottom properties if you want to. Change the offset value, smoothing percentage. That affects how closely the virtual wax up bottom surface is adapted to the framework. So if you bump that slider to the right, it will make a smoother surface and not as closely follow all the details in that framework. And then if it's a milled structure, you can specify tool diameter there. So we'll click Apply to use the default settings here. Then we'll begin calculating our wax up bottom surface. So once this step finishes, I'll show the expert mode tool that allows us to freeform that framework file, which is a new feature as well. This will take a few more seconds to calculate the surface. It's a pretty heavy calculation intensive step here. All right, it's chugging away. We're getting there. All right, so we're gonna make that last little bit here. Let's see. There's marked. So like I mentioned, let's jump to expert mode first. You can click on the framework file. Then we have an option down here that says freeform partial framework. So I can click on that, and that will make that framework STL file editable with our freeform tools. So we can go in, use anatomic tools or freeform tab, come in. If you notice areas you want to do additional smoothing on or bulk up or thicken any areas, you can do that here. Plus minus tools, smoothing tools, and you can really touch up your framework without having to go back to PartialCAD and reload the case there to do editing. So you can see if I change something, click OK, it's asking if we want to save over the STL file with the modified one here. So you have the option of choosing yes or no there. So I'm not going to recalculate our wax up undercut surface again. So I'm going to click no on that, and then we'll jump back to the wizard here. So now we're back. The surface is already calculated, so I'll click next. Now we're at the gingiva design step. So now we're on teeth 18 to 20. It's asking us to draw the outline of the virtual gingiva for that side. So it's going to start left clicking to place points here. Going to go off the framework a bit. Back up and then double click on our first point to close the spline. Once it closes, it'll automatically start calculating the virtual gingiva surface. Settings here, you can adjust your base thickness, cervical thickness, and then smoothing value. Again, that's the smoothing one is another one that will determine how closely the gingiva follows the shape of the library teeth there. So if you bump that more to the right, it'll be a flatter, smoother surface. So after that calculates, we can go in if we want to edit any of the border lines. You can click and drag the green control points. If you need to make any adjustments to where the virtual gingiva surface extends to, this makes some changes and then click apply again to recalculate. Looks like a couple points went stray up here. Let's bring those back up to our finish line surface. And then we'll go and calculate the gingiva design on the other side of the arch here. All right, that looks good now, so let's click next. Now we're designing gingiva for teeth 29 to 31. Again, I just left click to place our outline points. Back up and double click on the first one, and then the software starts calculating. All right, that one looks pretty good. Okay, that looks fine, so we'll click next. So the next step in the wizard is freeform gingiva. So here we can start off anatomic step, small and large regions, left click and drag on the gingiva to adjust its position. Usually this will be a good tool for adjusting our interproximal gingiva if we need to raise that up a little bit. To create sufficient material for the tooth pockets for these teeth here. The color map we see here is a checkbox over here, and it shows a thickness scale of the material over here. in the wizard panel. So on the other side of the arch, I'll pull up the interproximal gingiva here a little bit. And then we can switch to the freeform tab where we have add, remove, and smooth flatten tools available. So here you can use these tools to add any additional definition you want to the virtual gingiva. If you need to build out the root prominences a little bit, anything you want to define a little better here, we can do that. Add a little thickness on the lingual side here. All right, that looks pretty good. One useful tool I'll just point out real quick here, this checkbox that says keep bottom and boundary fixed. So if you get to this point and you notice that you want to extend the virtual gingiva a little further or maybe pull it up, that margin line that we made before can become flexible or editable by unchecking that box. So if I do that, then it lets me pull that up, or I can add material to extend it further down if we want to. So a really good tool there if you decide you want to change that border of the virtual gingiva at this step instead of having to go back. So that looks good. We'll click next. Now we're at the step where we need to calculate the tooth pockets in the overdenture that will fit our Pontic teeth here. So this step, this is really important in this type of appliance. So it's going to take into account the shape of the partial framework and maintain a minimum thickness of 0.4 millimeters over whatever shape of the framework is that we have. And then it'll automatically adapt our Pontic teeth to fit over that surface as well. So you can set up your minimum thickness for the material, a tooth pocket gap, which is similar to like a cement space between the virtual gingiva and the teeth, affecting our fit in the tooth pockets. And then depending if this is a milled or printed restoration, you can specify a tool diameter there. And of course you can uncheck that for printed restorations. So I'll click apply to do our calculation here. This will calculate our tooth pockets, and then we'll show you the shape of the parts afterwards and how they've been adapted to the framework. Pretty cool process. All right, almost finished with this calculation. So it's turned off our model scan, so we can take a look at the underside and you can see how that surface has been adapted to the partial framework. And if I turn that off, then we can see how our Pontic teeth have been adapted to fit over that surface as well. So those will fit right in, nice and accurate replication of the partial framework surface. So I'll click next. And that's the last step in our design process here. So let's turn these back on. Anatomic shapes. And then our framework. So then in the project directory for the case, we'll have our STL file for the framework, 2 STL files for the virtual gingiva sections, and then 6 for the separate Pontic teeth here. So that's the end of our presentation. Friedemann or Michael, any questions or anything you guys want to bring up or share?
Yes, there was. Oh, you go first.
No, go on.
Okay, there was a question about the parameters for the partial framework in the end when you merge the whole pieces. What are the settings you can use there?
Oh, okay. In the last step we were just at, let's jump back here. Maybe they're talking about the tooth pocket calculation step.
No, in the partial framework software. Sorry.
Oh, in the partial.
Yeah.
Oh, okay. Oh, okay. Now then the last step where we build the framework. So let me see if I can load that up and get back to that step here. This should be able to load our seed file to the end. So one setting I pointed out quickly as we were doing that was the checkbox to save the drafted refractory model, which will save that scan with the blackout on it. And then the other one, fill void check. This is a checkbox that will check if there's any open pockets inside the framework data, just due to how this is using voxels instead of surfaces. It's kind of rare that we'd need to do that, but that will check for any open holes inside the framework itself. And then the tolerance, I'm not exactly sure what that setting is related to. Do you know that one, Friedemann?
Yeah.
The tolerance, yeah. The tolerance is the difference between the STL that gets created and the file you see on the screen right now. So the triangulation of the STL has to be created out of this voxel-based file here. So the tolerance of 0 means that the STL is exactly the same shape. But if you choose a higher value for the tolerance, there's a difference. It's measured in millimeters or like the fifth.
So in fact, it's the length. So the value you enter here, it's the length of the longest triangle you can create. So the higher the value you enter here, the larger the triangles will get, and the smaller your file size will be. But you have a lower resolution then, which means so. I think if you go bigger than 0.025 or something like that, then maybe, Friedemann, maybe you have an experience, then at the moment you will start seeing a difference in the printing results.
Yes, I've been told that you can actually go as high as 0.1, which for me felt like really big, but still in the printing process, if you go casting it afterwards, it seems to make no real difference. But this is something you will have to try out yourself with your own printers to see if there's a difference. In the end.
I did a couple of tests in the past, and I found out that the value of 0.025 was a good compromise between having a good quality and a not so big file. But as we are here in this work step, could you maybe explain also the settings? So about the dynamic relief, the static relief, because we had a couple of questions, or I had a couple of questions and discussions here about fitting problems. So in general, quite easy. Of course, our default parameters will not guarantee a perfect fit because we don't know your manufacturing process. Are you milling? Are you printing and then casting? So there are different manufacturing processes and you need different parameters. Normally, you should get help from the support of your machine provider, which should be able to help you. And if that's not the case, then unfortunately, you have to do maybe tests yourself. And then I would start here, for example, here was a concrete question. Somebody was asking that the partials are always too tight. Then you should work here with the static relief and the dynamic relief. And you see here in the static relief, for example, you can create an offset. So the relief means it's an offset. You could also add an offset underneath the clasp. So you have to check out on your physical part, where's the fitting problem? Is it on the clasps or on the main connector? And then you can test different parameters here in the relief settings. I would then do, for example, tests with, I would print 3 or 4 partials, put a number on your partial. It's quite important. Otherwise, once you have found a nice result, you don't know the parameters anymore at the end. So write down the parameters you used with a number for each test. And then I would start with differences, for example, of 0.05 millimeters. So start with 0, then the second one with 0.05, and then 0.1. and then you can check the result on your physical part later. Maybe Lucas, you can explain us a little bit the difference between the static relief and the dynamic relief?
Yeah, I don't have personal experience in manufacturing the frameworks with the two of those settings. I'll just kind of add that this is really useful that you are able to add the relief for different components here instead of just under over the framework overall. As far as for how the static and dynamic differ as applied, I'm not quite sure. That might be something I have to follow up with in email, unless maybe Friedemann, you know that one.
Oh, sorry, I didn't pay that close attention. I was answering other questions.
The question, oh, sorry, I was just asking if you knew the difference between the static and dynamic relief, how that setting differs between those two there.
There's actually a very nice video and presentation by Vincent, the developer of the software.
Oh, yeah, okay.
It's anywhere on YouTube. It's really explaining, especially the dynamic relief. It's quite hard to explain and also hard to understand, because this is really very mathematical and engineering stuff. So let's say the static relief, this is very easy. Here you can define offsets between different parts of your partial with values measured in millimeter. And the dynamic relief, this is just a percentage. And yeah, this is something hard to explain. To be short, it's a kind of tool compensation and compensation of bad scan quality and triangulation all together. So it's seeking for edges on the triangles and doing a compensation in those areas to create gaps in such areas who can create problems in the fitting later.
Mm-hmm.
To be honest, I have no experience with real values here.
Yeah, it's hard to suggest specific numbers, and like we said, it's something that we'll have to do through trial and error on your actual components, on your parts. Yeah.
Maybe ask. There's a nice group on Facebook as well. It's dedicated to PartialCAD users. Maybe you simply ask there, but please then specify what you are using. What is your manufacturing process? If you simply say, "Yeah, my partial is not fitting," yeah, it's quite hard to find an answer. Yeah, explain your printer, which material. If you are casting, then even if you are casting, then you have also influence on fit during the casting process. So there are so many variables you have to explain, and then maybe some people can help you.
So there was another question, or more like a request. One participant wanted to see again the gaps between the acrylic teeth and the gingiva and how this whole design looks in the end now.
Oh, okay. We could probably do that by taking
especially
a look.
the pockets in the gingiva themselves.
Yeah, okay. So I'll open up one of our prosthetic-based STL files here, and we can point out some features here. So top side, for example, these are the tooth pockets that were calculated, and the minimum thickness that we specified at 0.4 millimeters, what the software does is make sure that this material is about 0.4 millimeters thick over our framework file. And then any areas where that framework would stick into the tooth pockets there, it's been adapted to that. Let me, if I try a cutaway here. Yeah, we can see that shape as it goes over the dimples or retention areas in the partial framework. So this gingiva actually kind of dips down in those areas. And then let's open up a tooth file. Take a look at one of the teeth that's been adapted. So actually, yeah, this is a good one. So this is one of the bicuspids. This would be up against the minor connector, and you can see material's been removed from the tooth to make sure it fits up right against that minor connector, as well as down in the tooth pocket underneath. So all that's done automatically at that step to adapt the gingiva surface there.
Okay, thank you.
Sure.
So there's no other questions left. You explained
No.
everything way too good.
Awesome.
So there weren't that many questions.
All right. Yeah, if that's it, thanks to everybody for joining this webinar. Be sure to check out exocad.com/webinars. Take a look at recordings of past webinars as well as the topics we have coming up for the rest of this week and next week. So I hope to see everybody in some more sessions here. All right, thanks everybody.
Yeah, there's also a very common question after the webinars getting in by mail. People are sometimes asking to get an attendance certificate. So especially now with the COVID-19 pandemic, they need such a certificate maybe for the company, or I don't know. So normally you get automatically a mail after the webinar confirming that you joined the webinar. So, and it's written, today we start now to write into this mail that we confirm hereby that you attend the webinar. Okay, that's it. Thank you, Lucas, Friedemann, and all you guys for your time and being here. See you next time.
Bye, everybody.
Bye.
Bye.